Alright, grade 8. So this week we're moving on to Unit 1, Electrical Systems and Control. You'll find this on page number 95 in your textbooks. We're focusing mainly on page 95, 96 and 97 today. And we're going to discuss what an electrical system is. We're going to break that electrical system up into simpler parts and look at what is our input, our process and our output. We'll discuss the different types of input devices that we get, as well as the different outputs that we get from this electrical system. And then lastly, we'll discuss what we use to control our system. Okay, so when we get started, you can read through page number 95 and 96 for yourselves, but I'm going to summarize everything into a nice little video for you that discusses all these things. So first watch the video, and then when you read through the information, it'll all make a lot more sense. Okay, so let's get started. Firstly, when we talk about an electrical system, we know that a system is comprised of many components that allow us to do work, right? Or they want to achieve a certain outcome. In this case, the outcome will be referred to as the output. So I've just drawn a standard circuit over here. So this is what they refer to as an elementary circuit. It's referred to as a simple circuit. Now you need to be able to identify what is the input, what is the process, and what is the output. Okay, so firstly, when we look at the input devices that you get, they talk about three main ones. They talk about, let's just quickly give them a heading here, input. Okay, they say it's broken down into chemical energy, generated energy, or solar energy. So when we talk about these three, chemical energy is pretty much a chemical energy that's stored into a battery or a cell. Right? Generated energy is using a fuel, most likely a fossil fuel, either gas, coal, petrol, etc., in order to generate current. And then solar energy uses a thing called a photovoltaic cell that will convert UV radiation or rays into electrical energy. It's important to note with the solar cell, you still need to have a chemical cell to store the energy, because the last thing you want is you're watching a TV program with your TV powered by solar energy, and then the sun sets and your TV shuts down because you haven't got any of that energy stored. All right, so solar energy and chemical energy go hand in hand. Right, and another thing, please, not to confuse yourselves between a photovoltaic solar panel and then a solar panel that's used to heat up water in a swimming pool. The solar panels that you see on the roof of the school, those are totally different from solar panels that you get to generate electricity. Right, so what I mean by that is the solar panels at school will slow down the flow of water, and they use convectional radiation, right? Convection. Heat transfer through convection in order to heat up the water. A solar panel, on the other hand, for electricity uses photovoltaic cells in order to generate electricity. Okay, so the ones at school do not generate electricity at all. They just slow down the flow of water, and then with the sun's heat heating up the solar panel, it in turn heats up the water and is pumped back into the swimming pool. Okay, so moving on, we now know how to identify our input. Right, and we've said now that our input in this case is a form of chemical energy. That energy then gets transferred across the conductive wires, and this is the process that the energy follows. Right, so there's a process. The process is pretty much converting the potential energy that's stored in our cell, right, into kinetic energy in the form of an output. Right, and lastly, we talk about the outputs. So the output can be in the form of four forms. All right. So firstly, it can be heat. Secondly, light. Thirdly, sound. And fourth, movement. So these are the four different outputs, and they'll always remain these four different outputs. You just need to be able to identify them. Okay. So in a test, I may give you an example of a TV, and I'd say, okay, now identify what is your input, what is your process, and what is your output. So you'd break it down saying that the input is the electrical current from the wall socket, which we know is generated electricity. The process would be the conversion of that electrical energy into an output, so from potential energy to kinetic energy, and the output would be in the form of light and sound, as well as a little bit of heat. So when you feel the back of your TV, the TV is obviously generating a little bit of heat, so therefore it is heat, light and sound. not movement. Please note the pictures on the TV move, but it's not the physical TV jumping up and down and running around the house. Okay, so there is no movement involved. Another example would be a kettle. Our input would be the same, our process would be the same, but our output then would be heat as well as sound and maybe slightly movement, because the main thing being heat, but then you can sometimes hear the kettle rapidly boiling, so we know that some of it is energy is converted into sound, and then when it rapidly boils, the kettle does move around or vibrate a little bit, so therefore there is a little bit of movement. Now the reason why I'm telling you this will all tie into efficiency. When you look at the efficiency of an appliance, you want to try and get the most out of your appliance. So I'll give you an example. In the olden days, you used to get an old-fashioned light bulb. Maybe some of you have still seen these light bulbs. They used to use tungsten wire or nichrome wire, right? And then what would happen is this light bulb, the electricity would flow through the nichrome wire or the tungsten wire, and this would glow red hot and in turn start generating light. However, now this light bulb was generating more heat, a lot more heat than the light bulbs that we get today, and therefore it was a lot less efficient because it had to generate heat first before it could generate light. Then we moved on to fluorescent light bulbs, okay, which use noble gas, and when you put electricity through a noble gas, it will glow. So the fluorescent light bulbs are the ones that you see at the school. All right, and this was able to generate light with a lot less heat, making it a lot more efficient. Okay, but they also did still generate a little bit of heat, and they had to use a starter to not ignite the gas, but to excite the gas in order to move up and down and generate light. And then you'll see if you go to macro nowadays, they use a thing called an LED, all right, that stands for light emitting diode, and those are obviously more efficient than a fluorescent light bulb. So efficiency comes on a bit later in the term, okay, but it's important that you know that each thing will give off more than one output in most cases. Only if a device was 100% efficient would you say that it only gives off one output, okay? Because most of the time it's going to give off more than one output, but you need to be able to identify those. The last thing being, with regards to our circuit in this week's work, is our control devices. All right, so here we have a switch that is closed. All right, so if the switch is closed, it means that it is allowing electricity to flow through and our output device will work. Please don't confuse yourselves. I know our brains automatically think if something's closed, it's not working. But in the case of electrical systems, if the circuit is closed, it means that the circuit is working and is completing the flow of electricity. If the circuit were open, all right, so an example of an open switch, it then breaks the current and therefore the electricity cannot flow through, and that means that the circuit would be off. So a switch is referred to as our control device, and you're going to learn about a few of them now in grade 8. So when we talk about control devices, we're referring to switches. The basic one being the rocker switch that you're all familiar with. Right? These are the switches that you get going into houses and so on. You also get a thing called a pressure switch. An example of a pressure switch would be a doorbell. So you push down on the switch, it completes the circuit, you release the doorbell, and the doorbell stops ringing. Another example, some of your bedside lamps will have a pressure switch. It will click into place and then you release it and it will click back. That's also an example of a pressure switch, and this is a symbol for it. Then you also get something called a slide switch. Right, that usually reverses polarity, so it's usually found in ceiling fans. So if you'll go from one side to the other, it will just reverse the fan going from clockwise to anti-clockwise, and that just means that the fan would either blow air into the room or extract air. And then you also get a thing called a toggle switch. So toggle switch will have more than one device that it controls. Right, so with the toggle switch, you'd be able to control, say, two things with one switch. As soon as you switch it on, and sorry, this should be here, right, and as this slides up or slides down, it will control both things at the same time. Okay, so you're able to switch on a light bulb as well as a buzzer, right, or a resistor or anything it may be through the same switch. That's how a toggle switch works, and these are the four main different control devices that we get inside circuits. So grade 8, just to revise for you and put everything together into a summary, you need to know what an input device is, right, and be able to identify what your input is. It's either going to be in the form of chemical energy, generated energy, or solar energy. Alright, you're then going to have a process where you convert that stored potential energy into kinetic energy into an output. The output will either be in the form of heat, light, sound, or movement. How do you control your circuit? You control it by using switches, and you get the different types of switches, which you'll see inside your textbook. Please know how to draw them and how they work. Alright, and then lastly, we just spoke a little bit about efficiency, saying that some of the stuff will be wasted in the form of either heat or sound or movement, depending on what we want from our circuit. If we want light from our circuit, we want as little heat as possible, as little sound as possible, etc. Okay.